Students, in our last class we have started the chapter polymers and we have seen important terms related with it and few classification. Now today we are going to see the classification on the basis of sequence of synthesis. So on the basis of sequence of synthesis, it is classified in two types: chain growth polymerization and step growth polymerization. In chain growth polymerization, the polymerization takes place by the addition of monomer unit in a growing chain. Okay, that means it will form a long chain, and over here the initiator is a free radical. Example of such kind is polyethylene, PVC, Teflon. Whereas in step growth polymerization, it involves a series of condensation reaction. Condensation reaction means where there is a removal of smaller molecules like water, ammonia, and the example for this is nylon 66 and Dacron. Now this is the classification on the basis of sequence. Now we have got the classification based on the molecular forces. On the molecular forces, it is classified into four types basically. One is elastomers, fibers, thermoplastics, and thermostatic plastics. We need to know the definition and example. Okay, so elastomers, they have got elastic character and possess weak forces. They can be easily stretched by applying stress and regain their original shape and removing strains. For example, rubber is an elastomer. There is a term called vulcanization. Vulcanization means to increasing the strength as well as elasticity of rubber. 3 to 5% of sulfur is added. That process we called vulcanization. Next we have got fibers. They have strongest intermolecular forces in the form of hydrogen, and they have got very high tensile strength, low elasticity. Example, nylon 66 and terylene. Next we have got thermoplastics and thermostatic plastics. Thermoplastic means the intermolecular forces in thermoplastics are in between those of elastomers and fiber. So the intermolecular force are between the elastomers and fibers. Okay, they form linear polymer chains with few cross links. They have hard at room temperature and become soft on heating. This is the property, and can be molded in any design, and you can convert into any desired shape. For example, polyethylene, PVC. These are practical experiments. When you just bond polyethylene, it will become soft. After cooling, it becomes hard. Thermostatic plastics, they are formed by condensation, polymerization, and have three-dimensional cross-linked structure. They do not soften. Now the properties of this is they don't become soft on heating, rather become hard. That means when we heat, it becomes hard instead of being soft, and we cannot mold it in any shape. They are more brittle. That means they can easily broken. Example is bakelite and terylene.